If you've never met me before, most folks know me from the SANS Institute. I currently have a class there, Sec 555, Sim with Tactical Analytics. It's cyber defense, catching evil, all the good fun stuff. A lot of things I like to geek out with that is going into container logs. Time permitting, we'll do that. But what I found is whether you're in cyber defense, you're in operations, maybe you're on the networking team, you just like computers. I don't know your story. I'd love to get to know you more. But containers are a bit intimidating. The first time I started playing with containers was way back with Solaris, and it was pretty painful. And then nowadays we've got, well, Docker, Kubernetes. We have all sorts of different orchestration platforms to auto scale out and auto scale down container environments. And if you're not familiar with any of these, I would really recommend you start with Docker. It's super easy to get stood up. It's super easy to start playing with it. And I'm hoping within this hour time frame, I can get you quick started, how to get it installed, how to interact with it, understand it a little bit. Because when I had to learn it, I did a lot of like video online training, read the docs. And it probably took me 20 hours to learn what someone could have showed me in an hour. So today, I'm basically trying to show you what I wish someone would have showed me in an hour. So, okay. For starters, the only thing I've done up to this point is I have 3 systems. I have 3 Ubuntu desktop. They're running version 2004. Technically, you could be on Mac and you can install Docker with Homebrew. If you're on Windows, I'm technically on a Windows box. I have Docker desktop. That you just download, double click, wizard driven, you've got Docker installed. I'm going to show you the Linux. This will be true of CentOS, Red Hat. Well, Red Hat's a little bit different, side story. But CentOS, Ubuntu, and most major flavors of Linux, Docker is really easy to install. So I'm going to walk through install, and then we'll start doing some use cases. So I've got 3 boxes. I'm just going to start with one for a second. So if I wanted to do this the lazy way, don't do this the lazy way. But if you're just mocking something up very quickly, you technically could do this. Sudo app install docker.io. Sometimes it's Docker, sometimes it's Docker CE. If this was CentOS, it would be yum install. So, I mean, slightly different variations, but built in, if I do an app cache search, docker.io, it's there. If you're not sure if it's IO, you can just do Docker. That's why I didn't just do Docker, is because there's a whole bunch of little helpers for it. So I could lazy install docker.io. Now, why am I not going to do that? Well, that's the repository built into Ubuntu or whatever flavor Linux you have. It's not a more current version. I don't want to be bleeding edge. There technically is a bleeding edge Docker repo. I just want to be more current on the latest stable release. So for that, I'm going to open a browser, and I'm just going to do Docker install Ubuntu. And I want the official guide, which is docs.docker.com. And really all you're doing is just running these commands. I don't need to do this. If you're on a fresh install, there's no old versions. If I accidentally install Docker.io, notice it's having me remove it because it wants me to be on the most current release. So I'm just going to scroll down here. You can run these commands. I don't need to do this, but I'll just show you. It's not going to do anything. I'm going to do this across all 3 of my boxes just so I don't have to do this later. The terminal I'm using is called MOBA Xterm. There's a free version and a commercial. I like it because I can control multiple things. I can do tunneling, separate video, but it's pretty cool, right? So I'm just running through setting up the repository, pasting this in. This is just installing prerequisites to get the Docker repo added. Now notice this is specific to Ubuntu. I'm just going to run this command. This will install the GPG key so I can trust the repo. You can see why just doing apt install docker IO would be easier, but this really isn't hard. Here we go. At this point, I actually have Docker in Ubuntu as the more official repository. So now, if I apt cache search Docker, notice there's a Docker CE there wasn't before. That's the community free edition, but it's the latest stable release. That's what I'm wanting to show for this. All the commands I'm going to show, even if I have time to go into swarm mode, they would have been the same for the built-in Docker IO. It's just this is a more current version. If you're going to use it in production, this is what I would do. Okay? And this is what I do for many of my clients where we do container deployments with SIMs, network security monitoring, and so. All right. And then I actually need to do the install. So technically, they want you to do another Pseudoapp update. I actually did that a second ago. And then run this. Again, I'm recording this. I'll post it. So I'm going through this fast just because the quicker I go through it, the more I can show you. So when this gets done, we have Docker installed, and I can now run standard Docker commands. And I'll demo Docker standalone on a single box first, and then I should have time that I can do a little bit of swarm stuff too. And I'm completely ad hocing this, so be prepared for errors. But again, if you have questions and stuff, drop them in chat. I'll try to monitor that here and there, or pull yourself off mic, ask the question, put yourself back on mic or mute, and we'll go from there. So, all right. This is almost done. 2 of the 3, just waiting on Docker box number 1. I've named these Docker 1, Docker 2, Docker 3 just to show you I have 3 boxes. The names don't matter. By default, if you join them to each other, that it works with IP addresses. I guess that is one more thing I will show you. I don't have a DNS server in this little mock lab, so I've added hosts entries. When you query DNS, DNS is actually not the first thing you ask. You ask your host file. So if I want to ping Docker 1 from Docker 2, it works because I have a host entry pointing to the boxes, and that exists on all 3 boxes. Okay, so at this point, we have Docker. I can now just run Docker help. I can see all the different commands. I'm not going to go through all of these because they're not all as important, and there's some kind of cheater steps we can do in here too. So probably the first thing we want to show is how do you run a container? This is pretty simple. You just need to figure out what you want to run. I'm going to demonstrate just a simple web server, Nginx, or Apache or something. I'll do Nginx. And the format looks like this. Docker run. Do you want to run it in the background as a service? That would be a daemon. Let me actually increase the font here for you. Or do I want to run it interactively? I'm going to do this first one interactively. Still increasing font. Keep going. And that should be good. I'm going to do an interactive terminal. You'll pretty much always do an interactive terminal, or you'll run it as a daemon, a service. Let's start with this. I'm then going to tell it to run an image, Nginx. Where does it get that from? Well, by default, it's going to reach out to this thing called Docker Hub. And this is where you can search for pre-built images. Do explore, type Nginx. There it is, Nginx. Now you notice a second ago, the default showed things like Ubuntu. You can run an operating system as a container. Hold that thought because that gets really confusing, but yeah, technically you can. You wouldn't, but you can. And so I'm just going to run this as is. Permission denied. Okay, so what that is, by default, your standard user can't access Docker. You could do sudo Docker commands, or what I like to do is I edit the group, find Docker, and I just add myself in here. I'm going to exit, and then I'm going to reconnect to the box. Now I can run that run command. and it'll work. Boom. Now, what's happening is it's reaching out to Docker Hub and it's pulling down the image. Think of it as like a virtual machine template if you're a VMware fan. It's pulling down the image. No, they're not the same, but it's pulling it down that has all the stuff in order to run a container of Nginx. Now, once it got done pulling down the image, when I did the run command, I told it to spin off a copy of Nginx. And so what we're seeing is it's running, except one kind of weird issue here in that Nginx is running on my box, but if I look at this host and I do a netstat, I'm actually going to do a netstat for port 80. Nothing there. In fact, let me prove this again. My box can reach over to this IP. Let me just prove that. Ping. I can reach it. Yet if I go back to my browser and I try to hit it, it's going to fail. Wait. I'm running Nginx. Why can't I hit it? Well, so Docker actually creates kind of a software-defined network within the container environment. So in here, I have this Docker network, and my Nginx container is basically spun off on this backend network that's not reachable. In fact, on this exact box, I can't do a localhost 80, but I could have done 172.17.0.1. Actually, I don't even have an exposed there. So I can keep playing with this, and there's a way I can get it to reach it. But what I really want to do is stop this container, Control-C. It's no longer running. Docker PS shows me what's currently out there. It's not there. It technically still is. I'll come back to this. But what I'm going to do is I'm going to run this again, but I'm going to expose port 80 on my host to port 80 in the container. That's port 80 to 80. Let's try this again. Boom. It worked. Where'd the website come from? It's the default Nginx website inside the container. So I actually kind of have two issues right now. One, what if I want to change the website files I'm serving up? And two, when I stop the container, what happened? And I want to start there because I technically ran a container up above and then I stopped it. And I'm currently running another and it's stuck in my terminal. Like if I close this terminal, I just killed this off. Well, let's actually prove that just to validate that I'm not lying to you, right? I'm gonna go back in here, Docker PS. Oh, it's still technically running. It hasn't fully hung yet. Eventually that'll die off. But so there's this container here. If I do a PS-A, that shows all. This was the first one I spun off. And so I have two containers, one currently still running. It should eventually die. And the second one is the one I stopped. But what that means is when I stopped it, it didn't get removed. You have to think of containers differently than you do virtual machines. In my opinion, containers are really designed to be ephemeral, meaning when you stop them, they're deleted, they're gone, they're purged forever. You can technically run a container, you can give it a nice name rather than these auto-generated names, and you could keep it running forever. You could stop it, you could start it, and if you do that, that's fine. It's not really the intent behind containers. The containers are intended to run, but if you want to upgrade them to a new version, you delete it and spin off the new version. Hold that thought. I'll show you how to do this. So first thing I'm going to do is I'm going to clean up what I have. I'm going to remove this one. And if I go to remove the other one, it's going to bark at me because it's running. Cannot remove. That's fine. Similar to Linux, just add a -F for force. Goodbye. All right. But now what I'm going to do is I'm going to rerun my terminal. I'm going to give it a nice name, Nginx. That way it doesn't do a randomly generated name. And I'm going to add a --rm. which means remove it if it stops. Delete it if it stops. I'll still expose port 80. We'll run Nginx. Nginx is up. I hit refresh. Still working. I Control-C it. Docker ps-a. It's gone. It's permanently deleted. That's really how I want to run my containers. Okay, well, if I run a container now and I delete it, that's somewhat a problem because anything like any uploaded files, anything that's changed, that persistence, there isn't. Right. So what we do with containers is we run services. This is really why they're called microservices. But the data does not actually get kept in the container itself. It's actually outside the container, like over here. And when the container spins off, it attaches to some type of persistence, a volume, a bind mount, an NFS file server share, an S3 bucket, and there's multiple ways we can do this storage. So let's go back to this. I'm going to bring up Nginx here, because what I'm trying to figure out is where should I put my mock website? If I want to change it, have persistent website HTML files, where do they need to go? So when I scroll into Docker Hub and find my image, you'll see stuff like, if I have my own web content, I need to put it in this folder in the container. So it's always left to right. I'm exposing port 80 on my host to port 80 in the container. I also want to expose some files on my host to, on the right, the container. So let's play with this. Let's first create a mock folder. We'll just call it www. Well, I'll just call it HTML. Inside of HTML, I'm going to put my fake index.html document. This is a test static HTML file. Now I'm going to hit up. I'm going to go back to my Docker run command, but now I'm going to add a -v, which is a bind mount. Think of it as a volume, but it's not technically a volume. Kind of is. And I'm going to say on my host, J Henderson HTML, I want that to go to inside the container, this folder. Okay. Now, I can also make it so that the container, if it had a running service that was allowed to edit files, isn't allowed to edit them by marking it as read-only. I usually do that as a failsafe if they're not supposed to change. Nginx wouldn't have changed them anyway, unless the site got broken into, but different question. So, okay, here we go. And hit my test page. Here it is. So now if I delete the container, I didn't lose my website. The container is just the service providing access to the site, and it uses whatever files underneath the hood to get there. So we've got Nginx running. We've got a port exposed to the host. We've got static files. So far, so good. Now, got a couple other things like what if you need to create your own images? We're using the default Nginx image. So maybe I'll try to show you how to build your own Docker images as well as host them. But I also have another issue in that what if I want redundancy? What if I want to have Nginx multiple containers across multiple physical servers so that if I lose one, nothing happens. Like it just keeps working, right? High availability. Well, containers for those of you who are starting are great because I can spin things off really quickly because you'll find stuff like DNS Twist. This is a really cool tool. It's a domain name permutation engine. And instead of trying to install Python and get the proper requirements installed or do a Python environment, like a pip environment or anything like that, I could just scroll down and lo and behold, they have a Docker image of DNS Twist. So you literally, once Docker is installed, you run that command and magically it works. So Docker gives us portability of code that you might even execute once and then quit, or ongoing services. It's also really nice because if I want to have a bunch of different versions of things, like let's go back to Nginx for a second. When I click on tags, that's effectively the versioning. When we didn't provide, we just said Nginx, we got the latest. But if I was on version 1.2.0, show you this, Docker run 1.2.0, it's going to pull down version 1.2.0. Oh, well, looked into it, and version 1.2.0 has a vulnerability, or I want this new feature set that's only available in 1.2.2. Okay, stop 1.2.2. Boom. No more having to deal with all the different, it's not 1.2.2. See, I lied. 120.2. We'll get it right? And it's literally that quick. Boom. Now I'm up and running again, and I can very quickly do that. And I can auto scale and load balance, but I need to switch to a container orchestration platform. That's going to be Docker Swarm. It's going to be Kubernetes, and there's technically more than just those two, but those tend to be the most common. So let's flip gears for a second to a multi-server orchestrated Docker instance. So for this, what I'm going to do is I'm going to create a swarm. I'm going to do Docker Swarm init. Boom. I'm now a swarm node, Docker node ls. Currently, there's just me, right? But what I can do is I can take this command that it prints to the screen, and I can run this on the other two. I'm not going to do that. This current command will set them up as called a worker node. There's a manager, which this first box is the leader. It's a manager. And then there's workers. If you want a fully redundant setup, you really need at least 3 servers, and you want an odd number of however many servers you have to be managers. You don't want all of them, but I like to have at least 3. So what I'm going to do instead is I'm going to turn these into managers. So I'm just going to run this command, which it printed on screen, and it's going to give me a different join token. And I'm going to run that on the other 2 boxes. So here I can move boom. Again, I didn't do the sudo. I didn't add them to the Docker group. No problem. I'll just sudo these. There it is. Sudo boom. Give that just a second. There we go. I go back here, run Docker node list ls, and I've got 1 box is currently the leader, with the other 2 are managers. Otherwise, it wouldn't show that reachable. That also means I can run commands on all 3 servers, and they can do any function because they're all technically managers. If I had 20 servers, I still would probably only have 3 managers. The rest would have been the default worker nodes, which is this. Kind of important because if Docker 1 were to go down and the other 2 were workers, they would continue to run the containers they have, but it couldn't auto scale up or down or do new feature sets. Really, it actually can do some of that, but it wouldn't be able to do new deployments, and certain functionality would be lost because you need a manager. So have redundant managers. At this point, I have 3 Docker Swarm instances. At this point, I could continue running Docker run, but I could try to flip things to services like command line. I don't do that anymore. Really, I try to get in the habit of running compose files. So let's see here, and they're actually going to be slightly different. What I'm going to do is, well, we can show the command line. Docker service nginx. Boop, ba-da-doop, boom. I'll see if I can find the command for this. I typically only do these as compose files, but dun 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 dun. This way. Docker service, create. And in this case, this is the different way of running it, where it's part of the swarm instead of a standalone. And here I could put something like nginx. And notice it looks a little different. I didn't expose ports. I didn't do any of the functionality. And now if I do a PS, it just happened to be here. But if I do it over here, sudo It's not. But there's a good chance this could have been placed on Docker 2 or Docker 3 because they're all currently empty, so it could place them wherever. Instead of doing Docker PS, I really want to be doing Docker service PS. Service PS, and I need to do it for the service I just created, which is Nginx. Docker service ls, and it's this. I didn't give it a name. So now it's going to let me know it's running currently on node 1. It's been up and running for 45 seconds. And if there were more than one instance, I'd see stuff like that here. If I were in a more prod environment, no, I'm not going to show that because this is being recorded. I don't want to show you any client information, but it would just spew out all these different services that you're running. I can't hit this one because I didn't give it all the options. What I'm going to do is I'm going to remove this service real quick. And I'm going to set this up the way I really should have. But here it is. Notice the .1 means it's the first instance. If I were to deploy multiple of these, that would change. All right, let me grab, I'm going to grab this on a different screen real quick. What's called a compose file. Instead of doing docker run -it -p-v and all that stuff, which gets really long, you can write it in a YAML file, and that's what I'm going to use. So I'm going to grab one of mine that I use for various tasks. I'm going to stick with Nginx just as the theme we've been using. And let's see here. I will grab this one. I'll have to change a few things in here, but I'm going to create a file called docker compose.yaml, and I'm going to do this. There's this test the volume. I'll delete all of these but one. This will be what we were using a second ago. Home J Henderson HTML, which is going to go to here. Again, I got to figure out where the path is. You don't have to memorize all this stuff. You just have to have good Googling skills or know where to find the information. So that's where we're mapping that. I'm still going to expose 80 to 80. This is YAML, so weird spacing would actually break this. I'm going to put this back. And we'll still use Nginx. I'm going to call the service name just Nginx. I'm going to set replicas to 3. Placement, I'm going to pop off for a second, but I'll show you what that is here in just a second. This part right here just tells it to store behind the scenes in Docker all the logs that the service would be printing to the screen. Like when we ran the interactive terminal, it'll actually store it in a JSON file that we can grab later. And this down here, I'll explain in a second. You typically don't have this on here, but I love it. It's kind of important. I'll show you in a second. Oh, and you can have health checks. This is really cool because it'll know if your containers aren't running properly, and it will actually respin them off if they're down. And you can kind of control how often it does health checks, what it does, and it's really cool. So when you start getting into services or stacks, you get a lot more power in here. So here's what I'm going to do. I'm going to do docker stack deploy my compose file. Let me make sure this is here. Deploy. Grab this. And I have to give it a stack name that all this will be tied to. I'm just going to call it test. Now, when I check on my services, there's actually going to be errors this time. I know there will be, because watch what's going to happen. This is test. Nginx is what I deployed. On Docker 1, it's running. Docker 3 currently is trying to pull the Nginx image. Docker 2 pulled the image, but it's running errors. And now, see, this is what I'm expecting. Docker 1 is fine. Docker 2 and 3 are not. Does anybody want to guess why Docker 1 is working, but Docker 2 and 3 are not? Is anybody familiar with what I did that was a no-no? I'll give you just a second. I'm curious if anybody spotted what I did. Looking in chat. Nobody's chat. They use the same address. That's actually okay. I'm going to show you something really cool with Swarm because of that. It has to do with, if I look at this file, it has to do with this. Okay, so this path, if I do an ls on Docker 1, it's there. If I do an ls on Docker 2, it doesn't exist. Doesn't exist on 2 and 3. Yeah, there you go. Yep, you got it. So if I want to see the full message, what I can do is no truncate, and you'll actually see this would give you the answer. Hey, home J Henderson HTML doesn't exist, and you can see the node, Docker 2, same thing. And so it keeps trying to redeploy it, but it doesn't exist. Oh, so you mean, yeah, you got to manually make sure the files are all there. You have to rsync them, secure copy. If this was shared storage like NFS, that would have solved this problem. To be honest, my favorite way of addressing this is just using GitHub. Meaning I go in, I'll just show you real quick, github.com. We got time. And what I'll do is I'll create a new repository. Docker 101 demo. Mark it as private because I don't want anybody else accessing my files, right? Create. From here, what you'll need to do to make this work is you grab all 3 boxes and you can do a SSH keygen, just like if you're trying to do certificate-based SSH logins, but we're actually going to use this for Docker. So in here, okay, Henderson, SSH, I'm going to grab the public key of each of these boxes. I'm going to go to GitHub. Deploy keys is what this is called. I'm going to call this Docker 1. I'm going to make it where Docker 1 can edit the files. Since this is just us goofing off anyway, I'll make it so the other 2 can too. Often what I'll do is I'll make it where the other ones can't. They're just read-only. So Docker 2. If you later need to change this, you just delete it and re-add it. So it's really not that big of a deal. But you just delete it and then re-add it with that box checked. So watch what happens when I do this. Key is invalid. I must have copied it wrong. Boom. Add. There we go. So all 3 boxes are here. You can technically look up the command to create a repo from an existing folder structure, but since there's only 1 file, I'm just going to cheat for time's sake. I'm going to click on SSH here. I'm going to copy this link, boom, and I'm going to do a git clone paste, go. Now what I'm going to do is on this first box, I'm going to move my test HTML file in here. It is, right? So I've got my file. I need to add it to my GitHub. I need to commit it. This is going to bark at me because I need to run these commands. Just in HA security solutions.com. See, now you have my email address. So if you need any security stuff, SIM logging, reach out to me, right? I usually set my name in there too. Dustin Henderson. Git commit again. This time it'll work. Initial commit. Git push. And now on these other 2 boxes, if I were to git pull, there's my file. Same thing, Docker, git pull, there it is. And so technically what you could do is you could literally have a cron job on tab that runs every minute, and it does a git pull in that folder. Henderson Docker 101. I don't know if that's the right folder, but and git pull. Or if you look up, this changes a little bit based on the operating system you're using. There's a flag for Git that you can tell it what folder it is, but it's different on, say, CentOS versus, say, like Ubuntu. So really, I would not use the cd command. I would look up how the git command, what the option is to point at your folder. And usually when you point at the folder, it actually wants you to point at this hidden .git folder. So like if I was doing it, it's like -o or something like that. It would be git dash. I don't think this is the right flag, but you can look it up. Home J Henderson Docker .git and then pull. And I can just every minute let that run. And so anytime I make a change, I make it, commit it, push it, and within a minute, all the other boxes will get that change. Okay. Now I'm going to go back and I need to fix my Docker compose file. So in this case, what I want is I'm going to map my website to this folder instead. Oh. And I'm just going to rerun that Docker stat command. Notice it's going to say updating. And I just need to watch the Docker service PS for a second for test nginx. No, Docker 1 is restarting. Should be up in just a second. Watch that for a second. So it's starting with one node at a time because the other ones were in a failed state already. To speed this up, I'm just going to actually start over and just tell it go. I wanted it to spin off all three at once. I'm getting that error because I'm running commands too quickly. So that was just, it was in the process of removing it as I was trying to deploy it, and it didn't like that. So sorry, I'm just going a little too fast. Now look, all three are running. Ta-da! My test site works, hopefully. Nope, failed. Something's wrong. I think I forgot to expose the port. Nope, 80's there. That's that. It is barking at me. It does not like that. I'm not listening on 80 currently. Docker those ports. Make sure I've got that right. Ports. Yep. Let me pick a higher port just for a second in case it's still stuck on that. Give that a second. Redeploy. Oh, no, I'm going too fast again. Let me explain what's going on. So when I look at this, see how it says it's running, starting, and in a second it's going to change. Let's just put that on a watch. I have a health check in my compose file. So what that means is I cannot hit this until the health check completes. If I didn't have a health check, it would pass it directly to the container. Because I have a health check, it won't let me hit the container until the health check passes. There it is running 3 seconds ago. I also changed the port to 8080. There it is. So running. And now if I were to do the standalone Docker PS, notice it says healthy. It didn't say that before. It's because I'm doing this. Health check, try to curl against the website. Notice this is port 80. 8080 on the host gets mapped to the container on 80. The health check comes from within the container itself against itself. So this should be port 80, not 8080. Yeah, you're welcome, James. That's why I kind of did this live. I kind of knew I was going to make some mistakes, and I think it's important to see those. So here, let's show the cool thing with Docker Swarm that I wanted to show you. I'm currently in port 8080. I'm going to hit Swarm Docker number 2. It worked. Ta-da. Right? Okay, well, let's try Docker number 3. Yep. So I can hit any of the Docker boxes I have because they're in a swarm. And it works. Well, but if I do a Docker PS, right? There's one container on Docker 1. There's one container on Docker 2. I'm just going to do that. Sudo host has one container. Let's change this for a second. Docker compose. I'm going to change the replica count to 1, meaning I only want one container, not 3. And I'm going to do the Docker stack command again. Nice. And notice you could see I did it quick enough. You were able to see it still removing one more of these, and now it just disappeared. I would not have lost access to Nginx while it was cleaning up those other two. So if I go back to the first box, which is where the current one is at, I believe. Nope, it's actually in Docker 3. Wait a minute. The containers on Docker 3, yep, not Docker 1. There's no containers on Docker 1 right now. But 241 in my environment is Docker 1. Yeah, so what's happening here is when you deploy a service or a stack which deploys a service for you, it creates what's called an overlay network. This is the most beautiful thing about Docker Swarm. So what happens, I go back here and I do a netstat for 8080, and let me actually do nat key. That's not going to show it here. If you were to actually dig into this, 8080 is being controlled by the Docker service, meaning Swarm creates an overlay network. It's why I called this a software-defined network effectively. So I can hit 8080 on any of my 3 hosts, and it will route it to wherever the container is. And if there's more than one, it'll just route it to whatever one it can get to closest. If it's the box and it already has a container, sure. And I can actually change that behavior to round robin and various aspects because it's like having a load balancer built in. So even though I have one container, I can hit any of these 3 boxes. And even with one container, watch this. So hopefully this will work. I'm going to delete this container. Make sure I've got my watch command going here. Boom. Uh-oh, it's failed. I better spin one back off. And so while technically it's down, like I can't hit it right now, it's auto recovering and it'll be back up line here in, I don't know, 15 seconds-ish. We'll see how quick this is. So 13. It just has to get to where the health check passes. Oh, I'm lying, it's gonna be like 30 seconds. So give this just a sec. Keep going, keep going. If there was no health check, this would have been up in like seconds. I just personally really like my health checks. There it is. So it was about 30 seconds. It's back up and running. And in this time, deployed it to Docker 1. Again, there's no containers on any host, so it can just kind of randomly pick them. It does try to balance them based on count of containers. It doesn't really balance them based on CPU or memory. So if your boxes are different sizes or your containers, Nginx is different than, say, like an Elasticsearch node or a MySQL node or a Cassandra, right? You have to control placement then. Okay, so first off, this is really not ideal. I really kind of want to have at least 2 replicas. So before I get too far, let me just change this back. And actually, I'm gonna do 3 just so we can catch things, because sometimes it moves too fast and I can't show them. So I'll redeploy. But when I redeploy, go back to my watch command, I'm still up because all it's doing is spinning up new containers. But through that overlay network, it won't let you hit them until they're healthy. If there's no health check, it'll start throwing commands at them. Usually it'll give them a few. It won't throw commands to them until they're at least showing up as running, but that's in seconds without a health check. And by the way, the reason it's roughly 30 seconds for that health check is because I said every 30 seconds. Nginx technically starts in seconds. I could probably change that to 5 seconds to get my health check to go faster. There we go. There we go. So there's the one that I killed. That'll still show up for a little bit. But the other 3 are now all up and running. And again, here, if I wanted to change versions, say I want to go to the 122 or the I can even downgrade. Let's pick a different tag again. I want to downgrade Nginx to something we didn't use. Not Perl. We'll do 121.6. 121.6. Watch what this is going to do. Now notice one of them now is in a ready state, and it's getting its health check going. The other 2 are still running latest, meaning my site is still online. No matter which box I hit, even if it's a box that's trying to run the newer container, it stays online. Because what it's doing is it's waiting for the new version to kick off before it moves and takes another container down. It's a rolling upgrade or a rolling downgrade. That's it there. It just went, this is now up and running. So now it's okay, we'll shut down this one on Docker 1 and spin up the new one. And once that's done, it'll do the same thing to Docker 2. Again, that is one of the things I love. Like, I used to manage, thousands of virtual machines. I would much rather manage 10,000 containers than 1,000 virtual machines because I don't have to deal with patching the operating systems. I don't have to deal with all the different virtual networks. I mean, you kind of do still in containers, but this to me is just a lot easier to do things, and I can kind of auto scale this, whether it's on-prem or AWS or wherever. So, okay, let's see here. Kevin, you've got a question there. If I need to configure different containers to communicate with another, what's the best way? I'm going to show you 2 ways. First off, if you're just doing standalone, you're not Swarm, going back to Docker Run, I can still do standalone containers, by the way. Let's do, I'll do Nginx again. I'm going to do 80 because it's available. Nginx, okay? So I've got 80, well, let's not do Nginx here. Let me find some containers that need to talk to each other that aren't overly complicated. Actually, here's what we'll do. I'll make this really simple because I'll be able to show you something else at the same time. I'm going to deploy CentOS or CentOS, depending on how you want to pronounce it. So run this. I need to be on the same host for what I'm showing you because these are not part of the swarm. These are standalone containers. Okay. I am currently root inside of CentOS. To prove it, let me run ifconfig, and it's not going to work. Nope, not found. If I go back to Docker 1, ifconfig works. This is Ubuntu. Yeah, but I'm currently inside of a container right now, and I can run commands inside the container. In fact, I can even install Nginx here. I need to do a yum update. Oh, sorry. Let's try HTTP. Okay, so the default CentOS image currently doesn't have repositories loaded. I'm not going to take the time to load them. I can't even do NetGet. Okay, that's fine. Can I do a ping? I can do a ping. That's good enough. Good enough. So I'm going to run another container. This one I'm going to call, we're going to run the Ubuntu image, but I'm going to change something before I run it. I'm going to link it to CentOS. It's going to download the latest image of Ubuntu as a container. No such container, CentOS. I didn't name this. My bad. I'm going to give this a name, CentOS. There it is. Now this command will work. There it is. So now if I try to ping CentOS by name, Ubuntu by default doesn't have that. Update. I'm in Ubuntu in a container. So containers often are missing any non-critical service because you're not doing anything. There's nothing in here. There's no services. My Docker 1 box has hundreds of things running. Containers run the absolute minimum. They're really intended to run one service. We're goofing off, so I'm going to install NetTools so I can do ping. Now, if I try to ping CentOS, ping still not found, which means I have to install ping, app install IP utils ping. Just give me one ping. There we go. It worked. My containers can talk to each other. Ping Ubuntu. I didn't link CentOS to Ubuntu, but I linked Ubuntu to CentOS. So notice here, I can't reach over to the Ubuntu box. I'm not aware of it. But the Ubuntu container, when I did the link command, going up here, I linked it to a container named CentOS. So if you had a website that needed like MySQL, I would deploy MySQL as a container, and then I would link the Nginx or Apache to MySQL, which would allow it to natively call that container by name. Okay. Now, technically, if I do an if config, and I do an if config, I don't have that currently there. That's fine. It's going to be one IP less. So I can still technically ping the CentOS container by IP, and I can ping the other one. They can ping each other by IP because by default, Docker doesn't block direct IP communication. There's an ICC command that you can put in Docker that will actually block all container communication, even direct IP, by default. Linking will still work and services will still be able to talk. So Kevin, if you're doing Docker run manually, you would do -- link, or technically there's one more thing you could do. You could do -- network and give it a name like my test network. And as long as you deploy things on the same network, they can talk to each other by name. I still try to get in the habit, if you're running things in production, like as services, I would go back to Swarm, because the containers I just deployed don't carry over to other hosts. And in my service file, my compose file, I had a test network of test. And if I were to add another container to this, like we'll do Apache for a second. Grab all this. If I were to create an Apache container, which is HTTPD is the image, I can't use 8080 again. 80 is available currently. And I put it on the same network. Docker stack deploy. Notice it's now got a new service. Service ls, I can see them. It's currently spinning them up. The current status of test Apache. They're all downloading the image, and in a second, roughly 30 seconds, they'll be up and running. If Apache, for whatever reason, needed to talk to Nginx, they could talk via service name. You would just literally point at the service name. So in my service, I called the service Apache and Nginx. So anywhere inside those services, they could call to each other by name, because it auto creates a DNS entry for the service name. And even though there's 3 replicas of this and 3 replicas of this, Swarm will auto let them talk to each other in whatever's an efficient manner. So if this was MySQL and Nginx, Nginx could just say, I need to talk to the database using the host name of MySQL. Okay. So containers
Yeah,
are
thank
pretty
you
cool.
for that, Justin. That was a great explanation.
I got 2 minutes left. I was going to show logging, but you have a specific question, Kevin, or anybody? Because it sounds like I'm going to need to schedule another one of these if you're interested in how to grab logs from these. Okay. I'm going to show you how to get logs for troubleshooting in 2 minutes. But if you actually want to get the logs to like a SIM or something like that, plus you want to monitor the orchestration service itself in case someone's trying to hack into it, break into it, or do something they shouldn't, I'll show you that. I will post the recording on Twitter and LinkedIn. I'll give a link to it, probably like a OneDrive or a Dropbox share, and you can download it. So yeah. So okay, so here real quick, standalone command, if you're not doing swarm, would be Docker logs, the name of the container. If you just did Docker logs, it'll just basically print the current logs. If you want to tail it continuously, -f. So now if I go here and I go back to just standard port 80, which is on my first box, something's interfering with port 80. All right, well, don't worry about it. Let me show you the Nginx because I can get that one to go over and over. I'm just constantly hitting this with refresh. If I flip to Docker logs of my Nginx, boom, there it is. And if I keep doing it, anytime this container specifically gets hit, it prints. If you're doing services, though, where you might have multiple, like I have 3 replicas, it's even easier because I don't need to know the specific container. I just do Docker service logs -f of the service, and it will grab them from all the containers. Boom. And you can still see this is Docker 3, Docker 2. These are the container names. And so you can basically monitor for troubleshooting or whatever you're doing across everything in the service. So again, Swarm I think is better than standalone, but if you're just doing something for testing, standalone is fine. Okay. I will probably do another, whatever we call this, streaming, webcast, whatever, on logging at a SIM level container logs, as well as just other things. I try to do a lot of these. They're fun, and I like to help out. So if you're interested in doing this kind of thing or learning in this approach, follow me on LinkedIn, follow me on Twitter, shoot me an email, justin@hasecurity-solutions.com. We do cyber defense. We have our own SIM SaaS platform, and we do cyber. Just anything cyber defense, we basically do that. So reach out to me. Look for the video. I'll post that here in a second, and I'll shoot out more schedules and get things out there. If there's specific topics you have in mind, let me know. I will take it under advisement. I won't guarantee I'll do it, but you should see more to come, from case management to cloud monitoring to you name it. With that, everybody, thank you. Have a good day, and we'll keep this going. Thank you very much. See ya.